So hopefully this gives everybody a good foundation on what FIDO's been up to, what we're doing. We're going to transition now into the specifications presentation from Tony Nadalin. So Tony, come on up. Oh boy.
Happy birthday, Tony.
Is it Tony's birthday? Hey, Tony. Tony. Apologies, slight technical issue here. We don't have the deck. He's going to present off his. Can you help me?
What kind of connector do you have?
Okay, you're going to use this HDMI.
Go ahead. You have a display out. Do you have a display
Okay, I
out?
have a display port, yes.
Yeah, I don't know whether it will work with it.
Okay. I think it's cycling through now.
Okay. Sorry about that. So I'm Tony Nadalin with Microsoft, and I'll take you through some of the FIDO technical specifications. But the woman that asked the last question on OpenID Connect, there is an enhanced authentication profile that's going on in OpenID that ties how the FIDO authentication, the strong authentication works with OpenID Connect. So there is a linkage in there, but you'll need this profile that's not quite done yet, but it's being worked upon in the OpenID Foundation. So hopefully that answers your question. So as we know that there are always issues with how secure authentication is. There are, most of the passwords wind up getting stolen off servers, right? I think we're all aware of that situation. And they get phished and so forth, and and you wind up losing money in the long run. And so this is basically what the paradigm is today with cloud authentication. We have a user, they have a device, and they do authentication to the cloud. And usually this is with bearer tokens and stuff, or symmetric secrets and stuff. And so they wind up getting stored out in the cloud on the server someplace, and this is where a lot of the loss actually happens. And so, people use the same passwords, they get attacked, the server gets broken, passwords are compromised, and now they go and play with other accounts that may be on different servers, and this is how all your stuff winds up getting stolen. And these are all the issues here, right? It's hard to type a password on a phone, right? Everybody knows that. Too many passwords to remember. It'd be nice if you just had a phone and you could go up and authenticate using your phone, not having to do anything. And to some extent, iPhones get into that particular point in time with their Touch ID and stuff like that, right? But you want it to be able to be used on all devices, not just particularly an iPhone. And these are basically your threats that we have. And as we just discussed, the attacks happen on the server system mainly. There are also remote attacks on devices. There's replay attacks. and then what we wind up having to up top is the physical attacks, right? Your devices actually get stolen. There's issues with, physically attacking the device, trying to get the information out of the device and stuff. And so these attacks are very scalable, and they do happen out there. And so what we're trying to do is prevent these particular attacks from happening. And so how does FIDO actually work? We replace the device with basically what we call an authenticator. An authenticator can be different things. They can be USB devices, they can be TPM chips, they can be trusted execution environments in phones and other types of devices. So that's basically what makes up the authenticator itself. And so the authenticator can be separate from the device, or it can be embedded in the device. So you can imagine if you get a laptop with Windows on it and stuff, all Windows devices require a TPM chip to be embedded in the device. So you can imagine that Windows will take advantage of the built-in TPM chip. It could be that you have a USB device that could plug into a Windows device, and it could be a biometrics, it could plug into Windows Hello, et cetera, things like that that can be used as a device. And so this is basically, how this actually happens is, the end user is going to use the authenticator. The authenticator is the thing that actually generates the cryptographic keys and the signature. And usually to release the cryptographic operations, you need a gesture of some sort. Gesture could be a fingerprint, could be some sort of biometrics, it could be just touch a button, user presence type of situation. There are all sorts of devices out there that require different types of gestures. But gesture is needed to release the cryptographic operations. And then what happens is you wind up getting you get a packet, we'll go through the actual flows here, but you wind up getting a cryptographic signature that goes over to the relying party, and the relying party winds up verifying that cryptographic signature. And there are many, as we just said, there are many forms of user verification, voice, biometrics, fingerprint, iris, PIN codes, et cetera. And the authenticators, can be TPM chips, secure execution environment, trusted execution environments, USBs, and even to some extent, smart cards can actually play a role in here. And so, so this is, once I get registered, and we'll go over the registration a little bit later. If you're coming back to a particular site, the relying party can tell whether that user's been registered on this particular site or not. And so you don't have to go through the registration phase. Every key pair is generated for a relying party. So any of the keys only get used with a single relying party situation. So there's no issue about collusion or anything else with the signatures and keys that go back and forth. So basically, this is the same. What we're saying here is, you want to make sure that the when you're coming to a particular relying party, you may have multiple authenticators, and you want to be able to have the right authenticator actually selected as part of your process. There's many ways as far as the keys to get protected. They could be protected by a TPM chip, which is, TPMs will store the keys wherever, and they will protect them so that you can't actually get the private key out of the TPM chip without some issues. Secure execution environment and trusted execution environment also will be a storage for your keys. There's also non-resident key situations where these are the TPM, SE, and TEE can be resident key situations, which means that you have the keys on the device themselves. There are situations such as YubiKey and some other devices that will store the keys in the server remote. So basically, the keys actually get transformed down to the authenticator each time in the protocol flow and then flow backwards. So that's another way. If your device is limited on its storage capabilities, you know, to keep the cost down of these devices, those keys can actually be in the protocol themselves without being attacked. There's also, I guess, Brent brought up some things about attestations. Attestations are basically what the device manufacturer creates. And the device manufacturer may create there's the TPM attestation, for instance, according to the TPM specifications. And it basically tells you what the device is about. It tells you it's a TPM chip by this particular company, and it's this rev of the particular TPM chip. And the attestations get sent upon both registration and authentication purposes, so that you can always tell what type of device the user is authenticating with. And there's also a metadata service. Since we don't want to chew up a lot of the bandwidth in attestations, a lot of the data is kept out on a metadata server. In the metadata server, you can take that attestation, look it up in the metadata server, and find out more details about that specific device, such as when it was manufactured, also whether it conforms to FIPS 140-2, what level, or 40-3, et cetera. So that's the purpose of the metadata service. It's a separate type of service that you can optionally use to find out more about the device, the authentication device itself. And so you have the option at registration time to reject this device. If you don't like the device, you don't like the attestations that actually came through, you can reject the registration of this particular device. And these are the things that the Authenticator actually takes care of. It takes care of user verification, user preference, takes care of, you know, transaction confirmation display type of things. It holds your attestation keys and your authentication keys itself. So the authentication keys are per relying party. Your attestation keys wind up being per device. And the same thing we have with a trusted execution environment and the FIDO Authenticator. You know, we have this particular, we have a trusted application that runs in the T. It has the storage for authentication keys and attestation keys, and it winds up going through the unlock process through the gesture process. The FIDO use cases, we cover both the passwordless experience, right? You don't want to use a password. We also cover the second factor issue. And so you may just want no password at all. You also may want to have, you know, as a transition into this FIDO world, you may select to use the second auth factor. It depends on what your situation is, what your deployment is, and what your you know, requirements are behind you know, how trusted you want this thing to actually be. This is the registration process. So every authenticator, every FIDO authenticator winds up going through a registration process with a relying party because the keys are generated per relying party. And so I will generate a private key for each relying party that I wind up going to. And what's nice here is I have this thing called a client data. And client data can be a lot of different things. It's whatever the client, in this particular case, the browser or the application, can actually store. And so the client data could be some PKI credentials, could be something else. And that winds up getting signed as part of the signature that goes back and forth between the authenticator and the relying party. And so this client data can become very important in how you may do privileged access and things like that, or how you tie public key infrastructure to the FIDO authenticators itself. So if you've already got a CAT card or a PIV card or some other smart card, you can actually bind that to the FIDO authentication process within the client data, and now you've got a way to tie the two authentications actually together. And then once you've gone through the registration process, this winds up just being the normal authentication after that. And basically you have an RPID. The RPID is how I might find the relying party, the key, the private key for the relying party that got generated on the authenticator. And so what's going to happen is it's going to verify and find the private key and regenerate the signature that's needed to go back to the relying party. So that's how you go through the registration process once, and then this is the flow that happens all the time when you do authentication processes. The building blocks for FIDO wind up being, the FIDO device, relying party application, the FIDO client, the ASM, which this is basically built on UAF, which was the first predecessor, which was the first FIDO implementations or set of specifications out there. And as you notice, that this required a particularly heavy client stack with the relying party application, the actual FIDO client, the authentication interfaces, the ASM, and then how we bind to the actual authenticator. And so moving ahead, what we wanted to do was to try to reduce that client stack to almost nothing. We wanted this to be, the whole TCP/IP stack issue again, right? We wanted to, that you didn't have to install TCP/IP. We wanted it so that, as the operating systems evolved, they included TCP/IP in the stack. You don't have to worry about a separate install. And so that's the stage that we're at right now with FIDO, is trying to get it built into the various platforms, browser platforms and operating system platforms. And so we actually have been, as Brent said, we actually have been working with the W3C. There is a working group going on in the W3C called Web Authentication Working Group, and this is where the work for the JavaScript API is being done. And basically, this is, the server is going to deliver a set of JavaScript down to the browser, and the browser is going to execute that JavaScript. And part of the JavaScript is, let's go find the authenticator and deal with the hardware underneath that, such as the USB or the TPM chip, et cetera. Up until this point, JavaScript didn't have any interfaces to deal with how it talked to the hardware devices, the crypto, et cetera. And so this work is how we actually allow the browser to go down into to talk to the TPM chip, to get us to send it information and get a signature back. There's also work going on in the W3C that we combined with also, which is going on in the web AppSec area, which is the credential work. So there is work going on to create a credential object in the W3C. And this could be a password credential, it could be, and it could also be a FIDO type of credential. And so what we wanted to do was to tie into the work that's been going on in W3C in the credential area, so that you could have one credential object, whether it be a bearer token type of password credential or a FIDO credential, that you didn't have to have different programming models for dealing in the web for dealing with different types of credentials. And so those are pretty much step locked as far as the work that's going on. So the web authentication work actually fits in underneath the credential work that's going on. And that draft, it really should have been draft number 5, not draft number 7. And so we put this out in December. It's out there. And this is basically the implementer's draft. W3C doesn't have they don't really have a thing called an implementer's draft, but we needed something that the browser vendors could snap to as they start to produce code.
The current draft is May 27th.
Yep. Yeah, this is I don't know what happened here, but thank you. And so we're on working draft number 5, WDO5, getting ready to go to WDO6, and then probably into candidate recommendation stage in the W3C. And so WDO5 is what the browser vendors are snapping to, and so you should start to see some prototypes out there in Edge and in Chrome and in Mozilla Firefox, et cetera. And they will implement the 5th working draft. And then once we get interoperability going, we'll move it into the working draft 6 and then into candidate recommendation CR, which will be, close to being finalized. And we hope that will be towards later this year. As I said, this is the browser application, and basically it's going to deliver the JavaScript down to its job is going to be delivered the JavaScript down to the client, and the client winds up executing that particular piece of JavaScript to do the actual authentication. That means that you can have the same JavaScript being delivered to a different browser, and it will execute the same in any of the browsers. You're not going to need any specific Chrome JavaScript versus Edge JavaScript versus Mozilla Firefox JavaScript. And so as you see, we've eliminated the stack quite a bit. We have just the browser now and the platform and how they bind to the particular authenticator. So there will be almost zero code that besides the JavaScript that winds up getting delivered to the client side. So there's no client-side application that you'll have to maintain. You'll get it when the platforms ship, such as Android or Chrome or any of the other platforms that exist out there. And there's this notion of external authenticator. The external authenticator, as I pointed out, if you get a particular Windows device, we'll have what we call a bound authenticator, which is the TPM module that sits within the Windows within the Windows device itself. But it will still allow external authenticators to be there. And that's what we call for the external authenticators. This is the client to authenticator protocol. That work is being done over in FIDO, and it's basically how do I communicate over USB, BLE, and NFC. Those are the 3 current transports that we've been working on. As far as the CTAP protocol is concerned, we're in working draft 2. We expect to go to working draft 3 very shortly, and then into implementer's draft within probably a couple of months, maybe a month, depending on how we resolve all the open issues. But there have been some interoperability things going on, tests, whatever you want to call them, between vendors, between the device vendors and the platforms. So the platforms are starting to implement CTAP, and we're shaking out all the bugs, the issues that happen there. And this is basically the WebAuthn APIs. You know, once again, we have the credential object plays a key role here, and this is off of the WebAppSec Credential Work. And so I'm going to have a public key type of credential, not a password credential. And then I'm going to do a create. And that's about all that happens here. So I form my credential, public key credential, and then I call the create, and it's going to wind up creating the keys that are necessary. And then what I wanted to wind up doing is, after I've done the create, which is actually the registration, I'm going to wind up doing a get, which is I want to do a verification of that authentication coming in. And so I'm going to wind up doing a credentials get in this particular case. And it's going to wind up verifying the credentials and sending the response back. So there's, you know, basically two JavaScript web APIs that will wind up being needed here. And then you can have your options and stuff. And so that's the JavaScript API. And as I said, we have the equivalent over in the CTAP area, which is make credential, get assertion. Those are those are the CTAP APIs that exist over there. So if you're writing an application and you don't have the particular browser, you can use the CTAP APIs to do the same thing as the web APIs. The two specifications are kept pretty much in sync. I think we're finally through making sure that the that the next working draft in W3C matches what the review draft of CTAP is in FIDO. And so they have the same functionality and they carry the same message, so they're totally compatible with each other. And this is, you know, as you can see, the convenience for password goes up. The security is pretty low. And this is where, you know, FIDO's sweet spot is, right? It's easy to use because we're not having to type anything. It fits on a particular device. And so you get the high security of public key cryptography without the need for a PKI system to back it. And you get convenience of being able to use your built-in authenticators on your laptops or your tablets or your phones, et cetera. And so in conclusion here, there are, you know, different authentication use cases lead to different types of authenticator requirements, right? You may want to do two-factor, and so we have authenticators that support two-factor. You just may want to have, you may be, you know, bound on the mission to just kill passwords altogether, and that's when you wind up just using the authenticator itself. And don't worry about the second factor authentication use case. But there's still, you know, some legislation out there that requires two factors. Some of the banking legislation still requires two factors, so you're going to, you know, we have to be able to cover all the use cases that exist out there today. There's also, you know, as I said before, there's also certain types of situations where you have to authenticate with PKI. And so that's where we've looked into how FIDO works with PKI and how to make the two marry together and be useful together. And, you know, I think as Brett said earlier, we've been looking at, you know, how FIDO complements, you know, federation and how you can wind up being authenticated using FIDO and then go ahead and do the federation on the back end throughout there. And I believe there's a white paper that's coming along somehow, and it will be out in the next couple of months or weeks or whatever the situation may be. So that's what I had as far as where we stand, you know, the technical specs, where we stand, what's the status of them, and, you know, and how we're going to move forward. So we really hope by the end of this year that the W3C work will be done complete, which will be the, beyond HTTP basic auth, which will be the only web authentication that, W3C's worked on since then. And so, so they've chosen the FIDO method to, to go after. And then we'll be probably done the CTAP work, so you get remote authenticators at the same time by the end of the year. And then we hope that the OpenID work will be wrapping up this year, which will say how we can use OpenID Connect with the FIDO authentication process. And so that should all be tied together. And so you can use OpenID Connect with a FIDO authentication mechanism if you've already deployed OpenID Connect. So, yes, any questions? Yes. Yep, so there's a layer. So basically the question is, we've got this JavaScript layer and it needs to access the USB and the NFC and the Bluetooth and et cetera. Yes, so there's two layers here. One is we've provided the JavaScript API that the platforms will support. And so the platforms wind up calling their native methods underneath that JavaScript API. And so when I'm building the browser, the browser implementations will wind up calling the native APIs, like on Edge. And Windows 10's browser is Edge. And we expose those cryptographic APIs at the platform layer, at the Windows layer, right? And the JavaScript implementation that's it's in Edge winds up calling those native APIs underneath to access USB and NFC or the TPM chip, et cetera. And that's where you'll get the combination of both the JavaScript web authentication APIs and the CTAP work underneath, because the CTAP work is how I take that and talk to the external authenticators over USB, over NFC, over BLE, and how I exchange the packets going back and forth. And if it's a bound authenticator, I'm going to use the normal, in Windows case, I'm going to use the normal drivers in Windows to talk to those particular sets of devices, such as the TPM. Can you give him a mic in case, so I don't have to, it's going to get complicated here. Okay, maybe you can just shout, so.
Yeah, so the use case I'm talking about, not-great user accessing your resource from really protected environment. They don't allow you to install anything on your system.
Right.
So how do you solve those use cases using this?
Right, so we've looked at those particular situations, such as military situations and stuff. And, bound authenticators work well in those particular situations where I have it bound into the device itself, such as the TPM chip, and so I'm not having to do anything external, plug anything into that particular device itself. So I can't bring in a USB key or an NFC type of device into those, SCIFs or wherever I happen to be working at the time. And we have bound authenticators situation that may work in those environments. So I've got the built-in TPM chip in those devices, and that device has been, it's gone through its certification process that the military or whoever your situation may be accepts that device as it sits, and therefore I'm not plugging in any external things.
Hi. So what are your recommendations for people who are already using FIDO 1.1 and they want to migrate to FIDO 2 project? I mean, is there a standard process for doing that, or is it backwards compatible?
I missed the beginning of that because I was looking for you and didn't see you.
So any recommendations that you have for people who are already using FIDO 1.1 and they want to move to FIDO 2?
So There are two different, so when you said FIDO 1.1, there's U2F and UAF.
U2F and UAF, right.
Okay, so U2F, the signatures, as far as U2F is concerned, we've now updated both the web authentication APIs in W3C and CTAP to support U2F devices. And so if you've got a currently deployed U2F device, you will not have to do anything to get it to be able to be used in in the platform environment when FIDO 2 gets deployed and all the platforms that are out there. U2F is a little bit different. UAF is a little bit different because it allows what I would call authenticator selection a little bit. It allows you to specify which authenticators that you want to be able to use, and that's done at the client side. And FIDO 2.0 takes the approach of you doing that over on the relying party side, where the computing power is much greater than sitting on the client side and providing an application that has to get policy and understand the policy and then filter out the different authenticators that you may have. And so what we've done is we've updated the charter in W3C to say, we will look at authenticator selection in the next release of the APIs. And so for right now, you can continue on with the UAF type implementations. They'll continue to run and work.
Okay, thanks.
I mean, the goal is, yes, to make them all so that you don't need to do anything once you get the platform. We're not 100% there.
So that would apply both on the client side as well as on the relying party. So it's not possible to seamlessly transmit the authentication channel through the relying party, so that the change is only on the FIDO authentication server.
Not yet. So, I mean, as far as U2F is concerned, yes, that's the case.
Okay, good, thanks.
But not the UAF side currently.
So I read recently that iOS 11 beta, Apple's decided to potentially open up the NFC chip to be used to other applications outside of Apple Pay. Mm-hmm. Do you know if any work has been done with any of the FIDO Alliance partners to potentially utilize that technology?
I can't comment on that right now, but you can imagine that us working on the NFC part of CTAP will be able to do something down in the iOS area. I just can't tell you, particulars of that right now.
Okay, thanks.
Anyone else? Oops. Oh, down here. What would be the re-registration process in case you lose your device?
Fun. You can use another device. So hopefully you've got a backup device, because you can use your backup device to bootstrap your new device. So if you lose one device, you can use another one to bootstrap and get you going again. If you lose all your devices, there's work to do, such as, I think as Brett alluded to, the first time through is a shared as a symmetric secret of some sort that would get you. Or you maintain a separate device that you don't lose, right? So, okay, appreciate it. Oh,
one last question, Tony.
Okay.
There's a question about Windows Hello. I assume Windows Hello uses U2F. Is there any future plan for supporting it on different browsers? Today it works only on Microsoft browsers.
You're talking about Windows Hello itself?
Hello, yeah.
I can't comment on Windows Hello running anywhere else but Windows, but you can imagine that.
Like, for example, on Windows, on Chrome browser, it's not going to work today.
I wouldn't go, I can't comment on that, but you can imagine that things.
No, I'm saying as far as the W3C standards are concerned, is there a API front work that is being done to integrate that?
So you can
that it works
imagine, as
seamlessly?
far as Windows Hello is concerned, you can imagine that CTAP would be the API that vendors would be the framework that vendors can plug into Windows Hello with. So it wouldn't be necessarily the browser set of APIs, it would be the CTAP set of APIs that, and so you'd want to make, and I'm not saying it is, but you would want to make Windows Hello CTAP compliant and
Got it.
have vendors plug into Windows Hello via CTAP APIs.
Okay, thank you.
Yep.
Okay, thank you, Tony.
Yep.
Thanks, everybody. Thanks, Tony.